Okay. It's time for the introduction of Professor Vicente González Romá. Vicente is also a well-known author in our field. He is professor at the University of Valencia, so the travel hasn't been so complicated in your case. And director of the Observatory of Graduate Employment and Occupational Guidance. He has been editor and associate editor of the European Journal of Work and Organizational Psychology, and currently he is an associate editor of the Journal of Applied Psychology and member of several editorial boards in different high-impact journals. He has a lot of experience about how to publish, so even in the round of questions you can also explore that field if you are interested. He published several articles in really important journals in our field, and as well he is an expert in statistics, probably one of the best in our country in this field as well, in joining the methods and the organizational side of research. Some of the interests are graduate and youth employment, organizational and team climate, leader-member exchange, job burnout, and other different topics. And today he will talk about a quite important topic, which is multi-level approach to organizational research, challenges and opportunities. So please join me in welcoming Professor González Romá.
Thank you. Okay, thank you so much for your nice presentation and for your invitation to come here to Madrid and share this time with colleagues from Europe and Spain. Okay, so when Alfredo invited me to give a talk here, one of the topics he suggested was the multi-level approach to organizations, and I said, well, okay, why not? So that's why I'm going to talk about the multi-level approach. You will see that I'm going to focus on three main issues that I think are important because, as researchers, we sometimes have to struggle with this approach, with the methods, with the requirements, with the demands of applying this multi-level approach. And I thought, well, it may be useful for everybody to learn or to discuss some issues that are relevant. Okay, so let's start. So, those who are involved in research in organizations, well, we know that organizational phenomena involve relationships, variables, and factors that reside at different levels. When we refer to a level, we refer to a specific position in a series of nested arrangements. For example, employees belong to teams, teams are part of departments are part of organizations. So here we have different levels within an organizations. And we know that sometimes what happens in a team or what employees feel depends on factors or depends on characteristics that belong to higher levels of analysis. For example, my sense of satisfaction may depend on the climate of the team which I belong to. So this is one of the examples that I will be using throughout my talk. Imagine that a researcher thinks that the team support climate impacts on employees' well-being. So here we are talking about a property of a team and an attribute of an individual. Here we have two levels involved. So in a way, this is a multi-level thing, a multi-level idea. Or another example is that the relationship between employees' burnout and employees' well-being, and this is an individual level variable, may depend on a team characteristic. For example, team climate. Maybe this relationship may be stronger or weaker depending on a team property. So here we have another type of multi-level question. So to fully understand this type of phenomena, we need a different approach. We need a multi-level approach. But this involves not only methods. This involves a different way of thinking. This needs different multi-level theoretical models, and this requires multi-level concepts as well. So we will be talking about these different multi-level models, concepts, as methods as well. However, we know that mainly in the last century, our discipline was dominated by single level approach, mainly the individual level approach. This has been very important for our discipline, and this approach yielded great advancement in our knowledge, but this approach cannot explain more complex phenomena, multi-level phenomena. Fortunately, the seeds of change were sown in the 80s and 90s, and there were two trends that converged in time. First, the multi-level paradigm in our discipline was started in the 80s and 90s, and we have some articles by House and colleagues, Klein and colleagues, Klein and Steve Kozlowski, Denise Rousseau, who started to talk about the necessity to involve different factors that reside at different levels: organizational culture, organizational human resources practices, team climate, team processes, and individual experiences as well-being, burnout, etc. So we have to take into account the different factors to understand complex phenomena in organizations. And at the same time, a group of statisticians started to develop methods to analyze these multi-level relationships. And here we have the works by Deleuze and Kret, Goldstein, Moutin, and others. And the convergence of these two trends really was very useful for the field. In this graph you see the number of documents published with the subject multi-level per year in the Web of Science. So you can see that it was, the curve was mainly flat, but then from 2000 on, there was a huge increase, right? So I think it was this convergence between theoretical models and methods that was really, really useful to begin to use more and more these methods, these theories, these concepts. This is good news because this really shows that we as researchers are becoming more and more aware that we need to use this multi-level approach to really understand complex phenomena in organizations. But the popularization of these methods, concepts, and models has also yielded some issues that need further elaboration and clarification. And these are the three issues I'm going to be focused on in this talk. One of the issues is the interpretation of the so-called cross-level direct effects in multi-level theoretical and research models and results, multi-level results. The second is the specification of the emergent processes involving higher level concepts that we usually have in multi-level models. And the one is about the sample size recommendations for using multi-level statistical methods. So let's start with the first one. Well, these issues represent challenges because we have to be able to deal with them, but also they represent opportunities for improving the research that we do, right? So the goal of this talk is to try to clarify these three different aspects. Okay, let's start with the first one. Well, the interpretation of the cross-level direct effect has been an issue of a source of misunderstanding. It has been discussed previously by different authors, as you see, by Pritchard and colleagues and by Lopilato and Vandenberg, but it continues to be a problematic issue. So in order to discuss it, let's start with an example that I'm going to use to introduce the multi-level approach, right? Okay, let's come back to our imaginary researcher, and she thinks that job burnout is related to well-being, and she thinks that this relationship may vary depending on a team characteristic, team climate, support team climate, right? So, in order to see whether she is right, what she does is to estimate a simple regression model in each team. Imagine that she has a sample composed of 100 teams, right? So in each team, she estimates this single regression model in which Y is the outcome variable, well-being, X is the predictor variable, job burnout, and then we have the slope and the intercept, right? So then let's write the same single regression equation, but in another way, right? This is the notation that we use in multi-level modeling, right? So, but it's the same. It's the same simple regression equation, but with a different type of Greek symbols. So here we say that for the subject I, who belongs to team J, right, there is a predictor, which is, in this case, job burnout. And because this researcher thinks that this relationship may vary from team to team, the intercept can vary across the J teams, but the slope can vary across the J teams. This is her hypothesis. So, although we have Greek symbols, it's a very simple regression equation, very simple, right? So then she goes and estimates this regression equation in her sample of teams, right? First, this is a this is an individual level equation because the predictor and the outcome are individual level variables, right? So she's going to estimate this equation in all the teams of her sample. And the picture looks like this. The picture looks like this. I have only represented 5 teams because representing 100 will be a mess. But so here we have that different teams show different regression lines. So what does this mean? She was right, because in different teams, the relationship between job burnout and well-being is different, right? So this means that in different teams, we have different intercepts, and in different teams, we have different slopes. So in some teams, the relationship between burnout and well-being is strong and negative. But in others, the relationship is null. There is no relationship. Why? Maybe because in some teams there is a strong climate of support, and this buffers the negative relationship between burnout and well-being? Could be, right? So if this is the case, the researcher may think, well, what can be explaining the differences in the intercepts and the differences in the slopes? Why some teams have low intercepts others have high intercepts, why some teams have strong negative slopes and others have null slopes? Why? Does it depend on a team level characteristics of the teams? Does these different intercepts and these different slopes can be explained because the teams have different climates? So this is what the researcher is saying in these two equations. Here again we have two simple regression equations, very simple. We have the outcome here, and here we have the predictor, team climate. And here we have the intercept and the slope, and then we have the residual term. So don't mind if we see complex Greek letters, but the key thing is that it's a simple regression equation. And what this researcher is saying is that the differences in the intercepts depend on team climate, and the difference in the slopes depend on team climate, right? And here we see that in these equations we have a team level predictor, and here we have two team level outcomes. Here, the team's intercepts are the outcomes of this variable. And here, the team slopes are the outcomes of these variables. So all what we have here are team characteristics. Team climate, team intercepts, team slopes. So that's why we call these equations team level equations, right? So we have one individual level equation, and we have two team level equations. And these equations form a multi-level model. And when we use statistical packages to estimate these relationships, what we do is to estimate all the parameters and residuals that we have in this set of equations. Okay. Frequently, what we have, when we have these equations, we combine them. And this is the individual level equation, and these are the team level equations. And what we do is replace this term with this expression, and we replace this term with this equation, and we have the combined equation. Usually we do this, right? So, and in this equation, we have different parameters of interest. We have the individual level relationship, or the individual level effect, which estimates the effect of your burnout on well-being. And here you have the representation. Then you have the cross-level direct effect, which is represented as you see here. And then you have the cross-level interaction. You see here a product between two variables. We know that this denotes an interaction effect, and this effect is represented as you see here. And it says that the relationship, the individual level relationship between burnout and well-being depends on a team level characteristic. Okay, so I'm going to focus on this effect because it's been a source of misunderstanding. By focusing on this combined equation that you see here and this graphical representation, I think that we researchers have frequently interpreted this regression coefficient as estimating the relationship between a team level characteristic and an individual variable. And this interpretation is inaccurate. I've done this wrongly too, but this is not accurate. So why? Why it is not accurate? So there are conceptually reasons. For example, a team-level property as support cannot explain within-team variability in employees' well-being. Why? Because for any team, this team characteristic is a constant. As you see here in this file, all the members belonging to Team 1, they have the same score on team climate. So there is no variance here. So it's a constant. This variable cannot display differences in burnout and in well-being. So conceptually, it makes no sense, right? Then, from a mathematical but simple point of view, you see that in one of these equations, we see that this estimate, this coefficient, which is the one that is named the cross-level direct effect, estimates the relationship between the team-level predictor, team climate, and team's intercept. It doesn't estimate the relationship between team climate and individual well-being. So what is the meaning of this intercept? What is the meaning? Let's see. So you know that in a simple regression model, as we have here, we can obtain the value for the intercept by using this formula. So simple. So if we apply this formula to this simple regression equation, we can write that the intercept is equal to this expression. This expression is the same like this one, but with subscript, but this is the same. So what's the meaning of the intercept? The intercept, it's a mean, an average in the outcome, but controlling for the effect of the individual level predictor. So the meaning of the intercept is an adjusted team mean in the outcome. It's not an individual level score, it's an adjusted team mean in well-being. Right? So as you see here, if instead of the intercept we write the equivalent expression, we can see that the so-called cross-level direct effect estimates the relationship between the team-level predictor and an adjusted mean in the outcome variable in well-being. It does not provide an estimation of the relationship between the team-level variable and the individual level variable. And this is important because all the time we are using this estimation as an indicator of this effect, right? So what can we do to avoid this misinterpretation? Well, one thing we can do is to avoid interpreting one thing what we can do is to focus on this level 2 equation instead of this equation, because in the combined equation, we see the outcome variable is the individual level 1. And, well, we can see, well, this is the effect of the team level predictor on the individual level variable. But this is confusing, right? We have to focus on this variable. Then we have to consider alternative ways of representing the cross-level direct effect. Because you see in a previous slide that generally this effect is represented as connecting a team-level predictor with an individual-level outcome. It goes from up to the bottom, and this is confusing as well. So as Sabina said before, every single level variable can be decomposed in its variance can be decomposed in individual variance and team level variance. I mean, I'm feeling satisfied because things that are related to my own job, but also because things that happen in my team. So part of the differences in well-being or satisfaction are related to team-level issues. So every individual variable its variance can be decomposed into a team and within team component. Team levels variables only have between team variance. So one thing that we can do, and considering that this coefficient estimates the relationship between components, a team level predictor at the between component of the individual level variable involved, this is a between effect. So we can represent this effect as it shows here, these graphs. Normally, what we do when we represent this cross-level direct effect is we draw an arrow from here to here. And I think this is confusing. It's better to represent this cross-level direct effect by just including this adjusted mean in well-being, what we really are predicting. Some of you I think some of you are familiar with M+. M+ uses this way of representing things. So this is not new. But I think we should start to using this way of representing things. Okay, another thing that maybe we can do is to replace the typical label as cross-level direct effect, because the cross-level term refers to this line going from the higher level to the lower level. And maybe we can use the between direct effect, which is a useful term in the M+ framework as well, right? And also I think that we should formulate hypotheses and interpret the associated research in a different way. For example, in manuscripts and in published papers, for example, the chapter by Lopilato and Vandenberg is full of examples. A typical hypothesis will be team support climate is positively related to employee well-being, blah, blah, blah. So we should say team support climate is positively related to teams adjusted means in well-being once team average job burnout is controlled for. So these are things that we should do to start to begin interpreting things in the right way. Okay, the second point I want to address is regarding the specification of the emergent processes involving higher level constructs. In our models, we normally use higher level constructs as team climate. And these constructs have the origins in individual level variables. When we measure team climate, we ask questions to individuals, and then we aggregate these scores, and we get an indicator of team climate, generally the mean, right? So, but an important point is how these higher level constructs emerge from individual level properties. How are they created, or how they evolve? Or this theoretical explanation is very important. Typically, researchers are mainly focused on showing that we have enough agreement to obtain the mean and use it as an indicator of the team level construct. This is important operationally. This is important. But theoretically, it is crucial to understand how this higher level construct is formed from individual level properties. And based on my experience as reviewer, editor, associate, I can say that many times this explanation is missing in manuscripts. And it's a shame, because this is what allows us to understand the nature, the very nature of this construct, of these higher level constructs. So that's what I'm going to address. And I'm going to focus on Kozlowski and Klein's chapter, the first chapter of the handbook, which they edited in 2000. And this chapter is really, I mean, you know, I know that many of you probably have read it, but I continually keep on reading it because it really changed my life as a researcher, I can say. Okay, so they distinguish between two main processes of emergence, composition and compilation. And then between them, there are many others, but I'm going to focus on these two. You can go then to the chapter to see the others. In composition emergence, the type and the amount of the individual level property is similar for all the team members of the unit. This is a key characteristic of this emergence process. For example, in the case of climate, you see here that all the team perception, all the individual perceptions refer to support relationships. So the type of the individual level property is the same. And in order to aggregate, we need to have similar amounts of support perceptions. And when we have this, we can compute the mean and use it as an indicator of team climate. Okay, so in this case, in composition emergence processes explain how these individual level perceptions converge and yield an higher level construct. For example, in organization climate theory, we know, and we have a lot of theories and empirical evidence showing that through social interaction, team members infect each other in a way, so they start to build this common environment, which is the team. So by talking every day, by communicating, oh, you see how the leader behaves, so have you seen this new policy? It's really supportive for us. So by talking about these issues, team members build this idea about the team climate. So we have other teams, for example, when talking about collective mood, we have theories about emotional contagion, social emotional comparison, etc. So we have theories. The problem is that many times we as authors don't use these theories to explain the emergence of this higher level concept. And this is really important. This is what I'm really stressing here. In compilation emergence, we have different scenarios. For example, in some cases, the amount or type of the lower level property is different, or both the amount or type of these individual level properties is different. So imagine the example of the performance of a basketball team. You need different types of individual level properties. You need different types of skills. For example, the point guard's skills, the playmaker, key skills are interpreting the dynamic development of the game, and he or she has to make strategy decisions, dynamic strategy decisions, but the center's skills are different, right? He has to occupy a good position under the basket, and he has to be very good at blocking the opponent's throws. And then the team members have different types of skills, but they can have the similar amount of these different skills, and they can have different, similar or different. So with this example, we see that team members have different skills, different individual level property types, and they can have similar amounts of different amounts, right? Okay, in the climate literature, we have an example that we introduced some years ago in a journal article, and which is climate uniformity. Climate uniformity refers to the pattern of climate perceptions within a team. And it represents differences within team disagreement in climate perception. We examined 3 different patterns. The uniform patterns, which is the typical one. I mean, when all the team members have similar scores on organizational support climate. Here you see all the individual scores are around 4, so there is a high degree of agreement in this case. This is the typical picture. But in a sample of teams, we were able to identify different patterns. Even in small teams, you can have subgroups which have different views of the team. In some cases, here you have some team members who have high values on organizational support. They think, well, yeah, the organization is supporting us. Yeah, we are happy with that. But then we have another subgroup saying, well, no, we are not receiving support from the organization. And this happened in a single team. So this is the strong dissimilarity non-uniform pattern. And we also found this weak dissimilarity support, in which here you have like an outlier. So all the team members think the same, but you have here an outlier, right? In this paper, we show that if a team has a non-uniform pattern, like this one and the other, then they have more task conflict, communication quality is lower, and they also have low performance. So it's important to look at these patterns, right? But the point here is that you see that climate uniformity emerges following different patterns. Not the typical one. When we do research on climate, we expect this pattern. And when we have this, we can aggregate data and we can use the average as an indicator of team climate. But here we show that there are other types of emergence, right? So in this case, the type of individual property is the same, perceptions of support, but the amount is different. Some team members think the amount of support is low, and others think the amount of support is high. So when this happens, we are in a case of compilation emergence, right? So compilation processes of emergence explain how different types or amounts of lower level properties combine to yield these higher order configural, not shared, configural properties. For instance, in the case of climate uniformity, we suggested that different processes can explain why team climate may show different patterns. Leader-member exchange quality, demographic diversity, organizational socialization. For example, in the case of leader-member exchange quality, maybe that a leader has good relationships with part of the team members and bad relationships with other part. And this then produce these subgroups within the team regarding climate perceptions, right? This could explain this compilation process of emergence. So even when we work with this type of constructs, and there is a compilation process of emergence involved, then we have to go to theories to explain how these constructs emerge. This is the point. To look back to theories to explain the nature and the emergence process of these higher level constructs. Okay. So, and this will allow us to understand the very nature of these constructs, because otherwise we are only playing with numbers. And yes, we know we can aggregate, but we don't understand the nature of these constructs. Okay, and then my last point is about a frequently asked questions. when I give seminars about multi-level methods, the typical question, and how many teams I need to do, how many individuals per team? This is very, very important. And we know that those who do research with teams or with organizations, we know that it's really, really tough to collect samples, because you need sample of teams or departments or units or organizations, and this is really, really tough. So, two useful sources of information to answer this question. The first one, the results of simulation studies, and the second one, power analysis tools, right? So, regarding the first one, last year we published a research on this issue in the annual review of organizational psychology and organizational behavior. With my colleague Ana Hernandez, we published a paper reviewing all the simulation studies carried out from the 80s until 2015 or 16. And with the idea of learning under what conditions these methods work better, right? And well, you can go to this paper and with the supplemental material that we uploaded, but some general guidelines, right? If the focus is on the so-called cross-level direct effect, then we can have unbiased estimates and a satisfactory power working with at least a sample composed of 30 units and between 20 and 40 individuals per group. So this is what simulation studies said, is that if you work with these conditions, probably you will have good estimates and good statistical power. And if the focus is on testing cross-level interactions, then what simulation studies say is that you will need 40 units and around 18 individuals per group. But another guideline is that it's better to have more units with fewer informations than the other way around. So the number of units is the key issue here. Well, a note of caution, because these recommendations are based on the specific conditions manipulated in simulation studies, and maybe sometimes these conditions cannot be generalized to real conditions. So that's why it's also useful to use the power analysis tools that we have. So these tools allow researchers to ascertain what sample size combinations they need to reach good statistical power values, taking into account different conditions. For example, the ICC, the interclass correlation coefficient of your variables, how much of the percentage of these variables is at the between level, the reliability of the measures, the effect sizes that you expect, etc. So when you put all this information in these tools, then you get a recommendation about the sample size that you need. And we have several tools that are in the internet that we can use. So if you are focused on cross-level direct effects, you can use these ones, and if you are focused on cross-level interactions, we can use this another one. So they are really useful, and the point here is to make informed decisions. This is the real point. So we know that throughout a research project, we have to make many, many decisions. And an important thing is to show others that these decisions were made based on sound grounds, on good evidence, good theories, good information, etc. And then, of course, we have to consider all the practical constraints that we have in the real world, because we are working with real work units, and nowadays many teams are very, very small, so you cannot have many individuals per unit, but if you know this, at least maybe you can increase the number of units. So, I mean, these are useful tools, and the point is to make informed decisions when designing the multi-level study. So, just to finish, so I think that we will be able to conduct better multi-level studies if we are able to interpret multi-level relationships in the right way, if we are able to explain how these higher level constructs emerge from individual level properties, and if we are able to design multi-level studies based on sound evidence and on informed decisions. So maybe by doing this, we will be able to do better multi-level studies, and we will be able to understand this complex multi-level phenomenon that we usually study in organizations. Thank you very much for your attention.
Okay, thank you, Vicente, for your presentation. I have some questions here, and again, I will give the audience the possibility to ask you. The first one is how to apply this approach to companies, and specifically is saying in an easy way, I mean.
The first, how to?
How to apply your approach to companies when they are making intervention or assessing something?
Okay, good question. I mean, what we usually do is, we have to sell the content of the project. For example, if we are doing a research project on team climate and the outcomes, we sell the idea that it's very important to know what climate looks like, because this is kind of thermometer of many things going on in the organization. And then we try to give them some benefit. For example, one thing that we do is that after we collect data, we write a simple but sufficient report showing them all the average scores that we obtain. So we try to sell the idea, and some of them, because of that, because they worked with us, then they keep on doing this thing, yes, for basing their human resources decisions on evidence. And the second one is we give them some benefit, some product, in exchange for their cooperation.
Okay.
So that's the two things that we usually do.
Okay, Vicente, thank you very much for your presentation. I have a question for you. When are you going to write a paper on how to capture the emergence of a multi-level phenomenon from a statistical and methodological point of view?
I mean, I think that Steve Skowlowski and Catherine Klein's chapter is so good that
you don't need
it can be complemented. It can be complemented with articles that studied the emergence of new higher level constructs. That's my impression.
But don't you think that there is still some work to do in the methodological field in terms of how to assess actually that something is really emerging? Because from what I know, there is not so much done right now, basically focusing on the evolution maybe of the ICC, and recent work of Paul Bliese and Lang and company. They show that actually the ICC might increase for different reasons. So I think there is a huge field over there. What's your opinion on that?
I think that there is room for improvement related to configural constructs. These constructs based on compilation processes. Because regarding shared constructs, I think that the process is quite clear, the procedure is quite clear. You have to look at agreement, and there is enough agreement, then you can compute an average. But related to configural constructs, as climate uniformity, there are several approaches. For example, in this paper, we used raters to code the different within team distributions of team climate perceptions. But there are other alternatives. For example, some people are using latent profile analysis. Yeah. So if you use the mean of every team, the variance of team perceptions within the team, an index for skewness and another one for kurtosis, you can find latent profiles that look like this I showed you. So we need to know we need to uncover the best approaches to operationalize configurable higher level constructs. And here I think there is room for improvement.
And even to capture the evolution over time, which is one of the big challenges if you think about emergence.
This is a really interesting issue, because these patterns of climate perceptions or patterns of well-being within teams may evolve over time. Yeah. Maybe at the beginning, everyone thinks very differently about the team. But over time, with interactions, communications, etc., they converge. But suddenly, a critical time event may occur. And then we may see subgroups within the same. So we don't know nothing about this. We can use some ideas to explain these different dynamics, but really we need more research on that. But it's difficult because you have to collect a sample of teams at different points in time, and then you have to follow them. And this is really demanding. This is not easy to do.
Okay, we have 2 questions in the room, at least 2.
Okay.
Arnold first, then Javier.
I would like to make the last point of Mirko a little bit more specific. So suppose that we are on board of a ship of the Norwegian Marine sailing from Bergen to New York. With on board we have teams of naval cadets. They are in teams of 8, and we follow them the whole trip, which is about 34 days. And we do this already 7 years, so we have data. So do you think that we could use, let's say, the deviance scores on negative acts like bullying in the first week or the first days of the trip? Can we use that to predict safety climate perceptions of the teams over the course of the 30 days?
I would say you can if you have a good theory to justify that.
Theoretically, it would make a lot of sense because it's very visible if somebody is a bully.
Yes,
so people may perceive, wow, I'm not safe here, and it will influence the atmosphere of the whole team, I would say.
You said that you would use deviance scores?
Deviance scores of daily reports of negative acts.
So
perhaps that's my question. It's not. I mean,
you can, but you need to know what this within team variability in
negative acts.
In negative acts, what's the meaning? Well, it's an indicator of social cohesion.
No.
Or
I want to know whether the deviant, so the individual who starts the whole negative process, whether one individual in one of the teams can create a sphere on board of the ship over time that is unsafe.
So you are focused on the deviance of a single individual.
Influencing the whole team. And my question is, how do I model it?
You can use that. And in fact, in Steve Kovlowski's and Catherine Kai's chapter, within the 2 poles of composition and compilation, you have different intermediate cases. And in one case, you can use the score, the maximum or the minimum score of an individual team member to predict team outcomes. So that will be your case. Is a single member enough to lead all the team to a later state of results or of...
But if I have a maximum score in a team, then the variance on that variable is necessarily very small, right? So you use the maximum score to identify a person who is the negative actor, but then the score, the variation on that score to predict team emergence of safety culture, that is very unlikely that you can do that statistically, right?
It will depend on the individual members that have the highest score in the other teams. It will depend on that. Because in that case, the individual with the highest score will be the indicator for the different teams. And you will be using this score from this individual with the highest score as an indicator of the team thing. And you will relate this highest score with team safety climate, team performance, or whatever. So it will depend on the highest scores in the whole sample of teams. Maybe you have a large variability or not. You will have to look at this.
I have to read the chapter, I think.
Javier.
So, thanks for your presentation. Great work, Vicente. My question is related to the first one that somebody asked. And, as far as I follow the logic of your presentation, what I see is that your multi-level analysis is focused on what we may call organizational internal stakeholders. You're referring to individuals, teams, departments, organization itself. But unfortunately, reality seems to be a little bit more complex. We have on top of those so-called internal stakeholders, we also have the what we may call external stakeholders. Stakeholders like consumers, investors, suppliers, lobbyists also have a great impact on psychological, organizational variables. So I'm not trying to find, or for you to find the philosopher's stone, but how can you capture that influence and conceptually and relatedly, methodologically, and integrate it into this multi-level analysis logic?
Yeah, well, it depends on the relationships that you are interested in. For example, we have conducted research with a sample of bank branches using clients' ratings on service quality as an indicator of team performance. We were interested in looking at how team climate is related to team processes and team outcomes. And as an indicator of team outcomes, we use clients' ratings. So this was a team-level approach. So this is one thing that you can do if you are using these external agents as providers of performance indicators. But, for example, in January and in February, I was giving a seminar on multi-level methods in two departments of economics. And they have a more macro approach. They work with organizations, but then they have variables that reside at the sector level. And then they have variables that reside at the country level. So depending on the relationships you are interested in, and depending on the theories underlying your theories, you can build these relationships. And I think you can also find ways to relate variables and indicators that come from external agents, as you said, to the variables that come from the internal ones. So I think that theory is the guiding principle, I would say.
First, thank you so much for your presentation. Which alternative would you suggest to calculator to assess the cross-level direct effect?
Sorry, can you repeat? What alternative?
Would you suggest to assess the cross-level direct effect? The
To
first
assess?
problem you signal, yes. The cross-level,
Yeah.
the direct effect, do you think there's some way to assess it?
I mean, what we have to understand is that conceptually, a team-level property is a constant for a given team. So you cannot relate these two variables. You cannot. You can relate a variable that varies across teams with another variable that varies across teams. And this variable is the adjusted average in the outcome variable. In our example, it was the adjusted mean in well-being, which varies across teams. And this is the point. So that's why when we model multi-level relationships, we have an individual level equation, and then we have one or two or more team-level equations. They are at different levels. And they model different types of variance. The individual equation models within team individual variance, and the team-level equation model between teams variance. So that's what we have to be aware.
I think now it's time for a multi-level coffee, a break. So half an hour and see you here, okay? Bye.
Thank you.